excitation-contraction coupling process. It begins with the action potential that travels down the motor neuron axon and causes a depolarization at the axon terminal. This then opens the ligand ion channel, which allows calcium to enter into the cell. This then causes the exocytosis of the vesicles that contain acetylcholine. The acetylcholine then diffuses across the neuromuscular junction and opens the nicotinic acetylcholine receptor, also known as NACHR. The activated NACHR allows sodium and potassium to travel across and depolarize the cell, which creates the end plate potential. The end plate potential depolarization creates an action potential that travels along the sarcolemma and enters into the T-tubule. The T-tubule is also known as a transverse tubule. The T-tubule then depolarizes, and the dihydropyridine located at the T-tubule changes shape to open the ryodyne receptor. The ryodyne receptor then releases calcium and begins the step 1 of the contraction cycle. The contraction cycle then begins, and we have our myosin head, our ADP and phosphate, our calcium, our actin, and our actin is also located across the tropomyosin line, and then we have our troponin, and then we also just have more ADP and phosphate. And then we go to step 2 of the contraction cycle, which activates the site exposure. In step 2, the calcium ions bind to the actin and create the active site on actin. The calcium also then combines to troponin, which weakens the bind of tropomyosin and troponin. Then we go to step 3 of the contraction cycle, which is the cross-bridge formation. The active sites then bind to the myosin heads and create a cross bridge. And then this leads to step 4 of the contraction cycle, which is when the myosin heads are pivoting. The energy that is released at the myosin right here, and then this causes the myosin heads to pivot the opposite way as the thin filaments are sliding towards the M line. This is also known as a power stroke. And then this leads to step 5 in the contraction cycle, which is the cross-bridge detachment. In step 5, ADP binds to the myosin head, and this breaks the link between the active site and the head. You could see it better right here. The detachment then allows for the exposure to make another bridge. This then leads to step 6 of the contraction cycle, which is the myosin reactivation. In step 6, the myosin heads slip and they break down ADP into ADP and phosphate again. And then this recocks the myosin head to restart the contraction cycle again. And this would more look like, this is our relaxed contraction, or it's the relaxed muscle. As you could see, the M line, we have our H band, our Z line, and our titin, which is long. And then for contraction, you could see that the H band has shortened, so has the titin line, and that's your excitation-contraction coupling process.